Machining slots is a common practice, and there is a toolpath dedicated to making this an efficient task. In order to do so, I have to set the proper cut parameters and calculate the appropriate tool size for this part. I have 4 slots, so I'll set the toolpath up for one of them, and when I'm happy with the toolpath, I'll add the other 3 slots geometry. To add the slotting toolpath, I'll select the 2D toolpaths, then slot mill. I'll chain the bottom of this slot. I'll select this edge, scroll down, select propagate along tangent edges, select the chains tab, select chain 1, and verify the arrows are correct. Then I'll accept this selection. When selecting the geometry, I'll be careful to always select it near one end of the entity, never in the middle, so that the arrow direction is the way I want the cutter to cut the slot. I'll select the Tool tab, followed by Select Library Tool, Filter, None. I'll select Flat Bottom End Mill as the tool type, and in the tool diameter, I'll set it to less than, and I'll right click in the size field to select D equals the diameter of an arc. I'll select this arc and right click to accept this. This slot is 3/4 deep, so when selecting the end mill I need to select one with enough flute length. I'll accept this so I can see what tools are available. One of these 3 have the flute length. I'll select the 5/16 and accept this selection. I'll set the cutting speed to 100, the feed per tooth to 0.01, the plunge feed rate to 20, and I'll add the comment, machine slots. I'll select the cut parameters and check that the compensation direction is set to the left. The compensation types were discussed in the introduction course. For this part, I'll leave the default setting of compensation in the computer. The slot will be machined as the graphic shows. The tool will ramp down into the slot to the depth of cut, then machine around the profile, arc out to the next cut, machine the profile, and continue this pattern until the slot is the correct width. The default entry/exit of 180 degrees is fine. I'll add 0.025 overlap, which means the tool will overlap its starting point by 0.025 with each loop. The overlap will ensure that the wall is all cleaned up. Since the slot width is 0.425 and the tool's diameter is 0.3125, the stock to leave on walls must be less than half the difference of these two numbers, or the toolpath will fail. Therefore, the stock to leave on walls must be less than 0.425 minus 0.125 divided by 2. This equals 0.05265. If I were to use a finished tool to machine the slot, the stock to leave on walls would need to be less than this, but since I'm only making one part, I'll set the stock to leave on walls to 0. And since the slot is through the part, I'll set the stock to leave on floors to 0. In the next lesson, I'll set up the rest of this operation's parameters.